Yeah, good morning everyone. So in this video, we will review about the concept of density. And as we know, the density is related with how objects sink or float. And then from the table, we can see different material have different density, different numbers. You can see like, for example, apple 0.83, and then we have titanium 4.5. Different material have different density. The unit of density is unit of mass divided by unit of volume, because the formula of density is mass over volume. Well, we know that. And yes, in this case, it uses kilogram per liter. So if you can see, different material, some material can sink, some material can float. Let's try to measure the density of the purple object. The purple box here has mass 19.3 kilogram, and then the volume, you can see the water 100 liter before I put the box, and then after I put the box it become 105.5. So the difference is 5.5 liter. That's the volume of this purple box. Okay, so let's just use some calculator here. We have 19.3 kilogram divided by volume 5.5, mass divided by volume, and then we get density 3.51, around 3.51. And from the table we see 3.51 is diamond. See, diamond 3.51. So the blue box is made of diamond, for example. And let's see about this blue box. Sorry, purple. The purple box is made of diamond, and the blue box is float. Maybe it's apple, gasoline, or wood. Let's find out. Of course, it will be less than the density of water. The density of water here is 1 from the table, and because it is float, the density should be less than 1. So it can be human, ice, apple, gasoline, or wood. To be more precise, let's calculate the density. Mass is 0.4 kilogram, and the volume, okay, you cannot just put it here because you must fully submerge all the object to find the volume. Not just a part of the object, but all the object must submerge. So I just need to pull it into the water before it is 100 and it become 101. The difference is 1 liter. So the volume of this blue box is 1 liter. Gak usah pakai, no need to use calculator. 0.4 divided by 1, 0.4. So as you can see in the table, it is wood, 0.4. So the blue box is wood. That's it. Density, very simple. But I want to push further. I want you to understand, not just calculate like simply mass over volume, but also understand what is density, what is more dense, less dense object. Maybe can we change the material density? Can we change the object density? So let's find out. What is density? What is actually density is? What is the difference between less dense and more dense object? Okay, to make it easier, I want you to, well, we know that object have particle inside. Object are made of particle. And then, for example, this is a substance. This is the object with its particle. And then I have another object that is more dense. You can imagine a more dense object, how it looks like. It will be like this, right? Like the same particle, but it's more dense, it's closer, the distance is closer, and yeah, it is more dense, lebih padat. It's like if you have a backpack and then it's full of books. There's a lot of books and it's very dense. Yeah, that is a dense object. And if I put the dense object into a less dense object, let's say this is a liquid and they can separate, the particle can separate. The denser object, of course, it can sink because it can push around the other particle because it's more dense. So that's the idea of density. It's related with the particle of the object, how close or how far the particle of the object. Now, next question: can we change the material density? Well, the answer actually yes, but it's not by cut or change its shape. Let's say cut, yeah, it's not by cut the object. Sometimes if you find a question like this: box with mass 8 kilogram and volume 20 liter. This is a wood. This is a wood, and then the density will be 8 divided by 20, mass divided by volume, and then we get 0.4 kilogram per liter, something like this. And then the question asks you again: what if the box is cut and the volume become half, or you can say become 10 liter? You cut the box, the volume half. If you only memorize the formula without actually imagine what happened with the question, then you will uh, maybe you will think like, okay, so the volume become 10, okay, volume become 10, and it means the density become 0.8 kilogram per liter. Oh, it become denser, the density is increased, and of course this is wrong. Why? Because if you cut an object, if you cut a material, it will not change the material. If you cut a box of wood, for example, like this, if you cut a box of wood, what you do is what you get is just two pieces of wood. The material will not change, and the density should be not change also, right? What's wrong here is this: if you cut object and the volume become half, the mass also change. Even the question didn't tell you that the mass is changed, but you must imagine, you must use your logic that the mass should be changed. So it should be like this one should be half also. The mass should also be half and become 4. So 4 divided by 10, it means the density will be same. It will be not changed. So this is the correct one. This one is wrong here. The density is not changed. So if we cut or change the shape of material, the density of material will not change. It will be the same. Even if we cut, we change, we blender the material, it's still the same. The density of the material itself is not changed. So how to change the density of material? There is a way, which is using heat. Of course, it will be related with the other topics about thermal expansion. If you heat an object the particle inside the object will be like, for example, like this. Nah, if you hit an object, you fire, you hit an object, it will make the, yeah, we will talk about this later, but the idea is the distance within the particle will be bigger. They will move further and further. The particle will move further, and the, if you can see, it will be less dense, right? It will be less dense. And this is the concept that is used for air balloon. If you have, if you see air balloon at the beginning, it's still on the ground. It's on the ground. The air inside the balloon will be same, have the same density with the air outside, of course, because they are the same air. But when you hit the air inside the balloon, you will make it less dense like this, and then it will make the balloon float because now it will become less dense. I will give you a picture to make it easier for you to understand. Thing like this. Yeah, you hit the balloon, the air inside the balloon at the beginning it is the same air with the other, but after you hit it, it will become less dense like this, and it will be float. So you actually change the density of this material. It can happen also in solid and liquid. Now, if we know that you cannot change the density of material by cut or change the shape, how could ship or submarine float on the sea? Okay, so if you are on the sea uh, and then you are uh, standing on the top of iron box and then you want to float, then you're crazy, you're stupid. There's no way an iron box can float. But how could ship or submarine float? Well, because the shape is different. For example, change the shape into, let's say the simplest one, drum, iron drum. Iron drum will float on the water, right? But sir, you say that you cannot change the density of the material if you cut or change the shape. How could the density change? Well, I don't say that the density of iron changes, right? The density of iron material is still the same. Okay, I repeat, the density of the iron still the same, but the density of iron drum is changed. The density of iron drum is less than the density of water, but the density of iron itself is not changed. So make sure you get the idea. Density of object versus density of material. The density of material is not changed, but the density of the object itself, like the density of the ship, the density of the submarine, it can be changed if you change the shape. Because as you can see here, there is a lot of air inside this drum, and then of course it has bigger volume, so it will make the density become less. And that's what is used for the submarine also. If you see a submarine, the structure of submarine is like this. Like this, there's a space inside the body of the submarine where we can fill it with water. We fill it in water to make it like heavier, be more mass, and then it will sink. And it can push or, and if you want to make submarine float, we can just fill it again with the air. As simple as that. So if we prove it using the formula, for example, formula density equal to mass divided by volume. Here I want to explain also why the mass is at the top and the volume is at the bottom. Well, Maybe you think, yeah, because that's the formula, sir. Yeah, but why? Why the formula should put the mass at the top and the volume at the bottom? Well, because in this case, if I want to make the submarine sink, it means I must increase the density. I can use, I can change the mass. I will increase the mass, increase mass, so I can increase density. I increase the mass by fill this with water. I fill it with water, and it will make the mass becomes bigger, and the density of the submarine, not the density of the iron, and the density may the, the density of the iron is not changed, but the density of the whole submarine, because the mass is increased, the density will be increased, so it will sink. That's the concept. Let's use the simulation here. Now, for example, like this, I have box. Let's say this is the red submarine and this is the blue submarine, and they have same size, they have same volume, but if you can see, the blue submarine is filled with water, so it's heavier, it will sink because it's more dense now. But the red submarine, they have same size, but the tank is not, there is no water in the tank, so it's lighter, the mass is less than the blue, so it has less density and it will float, even though they have same volume, same submarine. And that's the concept why mass is at the top, because it is directly proportional. You increase the mass, you increase the density. Volume. Why volume is at the bottom? Because it is inversely proportional. It means if you uh, decrease the volume, then you will increase density. It's the opposite. Decrease the volume to increase the density. The example you can use sponge, yes, sponge. If you have, you know sponge, right? If you have a sponge and then you squeeze it, you squeeze the sponge, it means you decrease the volume of the sponge, and it means the object, of the material, the sponge object density will be increased because the volume is decreased. Yes, makes sense, right? The part that your hand squeeze is more dense than the other part. And that's why the volume is at the bottom, because it is inversely proportional to density. Okay, that is for the video. Thank you for listening.